this stuff. All right. So the first question I have from the review session is, we want me to look at this particular problem. We actually did in class, but I want to look at it again. So let me pull this thing up. I'll put it up here, and I got a nice little sheet of paper underneath it. And I'm going to analyze it again. Okay. All right. It says this. For the sales function for a product is given by S of x equals 204 plus 6.3x squared minus 0.25x cubed, where x represents thousands of dollars of spent on advertising between 0 and 12, and S is sales in thousands of dollars. Find the point of diminishing returns. You're supposed to find the point of diminishing returns. Now, the definition of a point of diminishing returns is basically this. It is the point of inflection where you actually have to change concavity. So this point of diminishing returns is actually the point where you change from going from concave up to concave down. It is a point of inflection. But it's a very special point of inflection in the sense that you're changing from concave up. So you're going to, on a number line, you got your point of inflection. So we're talking about the second derivative has to be equal to 0 and solve. And you've got to actually go from being positive concavity to actually going to negative in concavity. Only in that direction, it's a special point of inflection where you go from concave up to concave down. Point of inflection, you just change concavity. But going from concave up to concave down has a very, very special name, and that is called the point of diminishing returns. Your returns are still good, but you're not, with that concave down, you're beginning to slope down a little bit, and well, you know, your sales are good, but they're beginning to slack off a little bit, and that's your diminishing returns. Does that make sense? So, what I need to do here, this is a point of inflection. What you need to know is this. How do I find these points of inflection? Points of inflection, also known as hypercritical values, you take the second derivative, set equals 0, and solve. You're taking the second derivative, set equals 0, solve, and where the second derivative doesn't exist at, second derivative, this is called the hypercritical values. And when they change concavity, when you check them out, then they become quote-unquote points of inflection. So the first thing I got to do this particular problem is I need to actually take the second derivative. So to take the second derivative, I've got to find the first derivative. Derivative of 204 is 0. The derivative of 6.3x squared, well, 2 times 6.3 is what? 12.6. This will be 12.6x minus the derivative of 0.25x cubed. Well, 3 times 0.25 is 0.75x squared. That was my first derivative. Does that make sense? Now I'm going to find the second derivative. Okay, my second derivative is, well, derivative of 12.6x is just 12.6 minus the derivative of 0.75x squared. Well, 2 times 0.75 is 1.5 or 1.50x. Now I'm going to set this guy equal to 0 and I'm going to solve. First move I'm going to make is I'm going to add 1.5x to both sides. This cancels, leaves me with 12.6 is equal to 1.5x. Then I'm going to divide by 1.5. And this is going to give me x is equal to, and put it on the handy dandy calculator here, is going to be 12.6 divided by 1.5 is 8.4. Now, if they want to find the point of diminishing returns, you can sit there and make this thing a particular point here by actually finding the y-coordinate. So you know your x is 8.4. To figure out the y-coordinate, we're just practicing here, you've got to plug it into what? The original equation. Not on the first derivative, we're not saying the original equation gives you y-coordinates. So the original equation is way back up here, which is 204 plus 6.3x, and your x is 8.4 squared, minus 0.25 times your x, which is 8.4 cubed. And I end up getting 500.352, some number there. But that's your point. Now, you want to prove that this is the actual point of diminishing returns. And so, here is my second derivative. We'll call him S double prime of x. Here's my 8.4. And here's the most important. And I should have checked just before I said anything. That 8.4 must be in the interval for which we define this thing. What did we define this thing from? Between 0 and 12, right? 8.4 is in between 0 and 12. Does that make sense? So now I'm going to check that. So I'm happy about this particular point because it's inside my interval. Because if it's outside my interval, just throw him away because he's not worth anything. We only care about inside your interval, between 0 and 12. So I don't care about less than 0, and I don't care about more than 12. So this is my interval. Now I'm going to show you this is a point of diminishing returns by checking out the concavity, second derivative, around this particular point. So I'm going to pick a point between 0 and 8.4. I choose 1. S double prime of 1. This is my second derivative. Just to remind you, your second derivative is 12.6 minus 1.5x. Bunch of decimals, but it's not too bad of a second derivative. When I plug in 1, that would be 12.6 minus 1.5 times 1. And 12.6 minus 1.5 is 11.1. I don't really care what the number is. It's positive. So everybody in that interval is positive. But because it's a second derivative, I know that is concave up. And now I'm going to pick a number bigger than 8.4. I choose 9. So f double prime of 9 would be 12.6 minus 1.5 times 9. And again, just literally plugging that on my handy dandy calculator. 12.6 minus 1.5 times 9 is negative 0.9. I don't care what the number is, it's negative, so that's negative. Now to answer the question. Notice I went from concave up, second derivative, to being concave down, negative second derivative, which makes this the point of diminishing returns. And they actually ask you in the problem, okay, you're supposed to find the point of diminishing returns, and that point is this coordinate point here, but it's actually the x-coordinate. The x-coordinate, okay? So what does the x-coordinate actually equal to in this problem? Because we're defining it for x. So x represents your thousands of dollars spent on advertising. That's what this x represents. So how many thousands of dollars do we need to advertise before we hit this point of diminishing returns? Well, x was equal to 8.4 in this problem, and x was measured in thousands of dollars, and that would be an appropriate answer. But honestly, you've got to communicate this stuff to your employer or your employees or your people that you're doing investing with, whatever. What does this $8.4 thousand actually mean? Talk about money. What is $8.4 thousand? What is that? That's $8,400. 8.4 thousand, and basically move the decimal place 3 places to the right for the $1,000. So 8.4 times $1,000, and you get $8,400. Does that make sense? So right at you spend $8,400. That's when you get your quote a point of diminishing returns, because you got it. You're the last point of on the upward slide. I mean, really just jumping into your sales are increasing. They're increasing at an increasing rate. They're actually going way up. At that point, then they're going to start slumping. They're still going to go up. So you still may want to invest, but how far do they go up? But the slope is beginning to start to decrease once again. Does that make sense? Diminishing returns. Yeah. If the point is not in the interval, then ignore it. Throw him out. You only care about, in this world, between 0 and 12. Okay, so if I ever give you an interval and you solve for something other and it's outside the interval, it does not exist. Just throw it out. There would be no diminishing return if that was the case. Right. If this answer was not in the interval, then there would be no point of diminishing returns between 0 and 12. Right. You're done. So always check your interval, what the function is defined over. Does that make sense? Another question. You guys good? Yes. Okay, cool. So if it's not in the interval, boom, throw it out, and then their quote is no point of diminishing return within that interval. There you go. Well, one of the things I wanted to kind of discuss with you guys was how I work on some of your Hawk stuff. So I've got And so I've reopened, and because of spring break kind of messed up everybody in terms of things we actually do over spring break, but that just messed people up. So quiz 6 is still open, but we're going to talk about that. So, and then I may even do certify 1.4a, which is actually due this weekend and stuff for you guys. So let's come over here, right here, and here we go, and let's take a look at quiz 6. All right, and I'm going to go ahead and start it. And let's see if we can answer some of the questions, because this is still from Chapter 5, but if you notice, Chapter 3, but you notice that Chapter 3 stuff, max, min is still very important, because we're still doing the same stuff. Take derivative, set equals 0, and solve, and where derivative doesn't exist at. All right, so this one is the intervals of increase and decrease. Determine the open intervals on which the function is increasing and where the function is decreasing. All right, so I'm going to switch back and forth from a screen to actually me doing the work. So f of x equals x squared minus 6x plus 14. Intervals of increase and decrease. Intervals of increase and decrease deal with the first derivative. So let me go back over here and click on, there we go. And so here is my problem. Before I find intervals of increase and decrease, I got to find the critical values. So I'm going to take my derivative. Derivative of x squared is 2x, minus derivative of 6x is 6, derivative of 14 is 0. I'm going to set it equals 0 and solve. So 2x is equal to, add 6 to both sides, equals 6, and then I'm going to divide by 2, x equals 3. This is my critical value. Does that make sense? The first derivative equals 0. Now, to find intervals of increase and decrease, that implied interval word means I'm going to draw a number line for the first derivative. Intervals of concavity is a number line for the second derivative. And on this number line, I'm going to put my critical value, 3. On the second derivative, I put the hypercritical values on those number lines. Now, do test values. Pick a number less than 3. I choose 0 because I have a brain. So f prime is 0, plugging into my derivative. 2 times x is 0 minus 6. 2 times 0 is 0 minus 6 is negative 6. It's negative. And pick a number bigger than 3. I choose 4. So f prime plugged into your first derivative 4 would give you 2 times 4 minus 6. 2 times 4 is 8 minus 6 is 2. I don't care what the number is. The fact of the matter is it's positive. And this is the first derivative, so it tells me I'm decreasing. So I'm decreasing on the interval between negative infinity to 3. And I am increasing on the interval from 3 to infinity. It also tells me that 3 is a minimum, but that's great. They didn't ask me all that stuff. But now, it's all about typing it in. So that's kind of what Sandis and I were working on in terms of trying to get these things to help you with. What about the intervals? The intervals of increase. So I'm going to hit a parenthesis. If you type an open parenthesis, it automatically pops up, or you can click on your keypad here. My answer was what? For increasing was 3, infinity. To get the infinity on this thing, you hit keypad, and you come over here and click on the infinity symbol. And then I'm going to go for decreasing. I will keep my little pad up there. It'll be from parenthesis, negative, and I click on the little infinity sign here, comma, and then it goes to 3. And then I can just click on this guy, and then I've done this problem, so I'll go to the next problem. This next problem is a two-parter, it looks like. So it asks you this. Part 1, consider the function, so let's write it down. It is f of x equals x squared minus 2x plus 4. Part 1, you're supposed to find all the x values that correspond to horizontal tangent lines. What's a horizontal tangent line? Well, tangent line is derivative. Horizontal slope is 0. It's where the derivative is equal to 0 at. It's a different way of talking about it. Okay? So let's find that guy. Where is this guy going to be the horizontal tangent lines? Where is the derivative going to be equal to 0? So here we go. I'm going to take my derivative. The derivative of x squared is 2x. Minus derivative of 2x is 2. Derivative plus 4 is 0. I'm going to set it equal to 0 for the horizontal tangent line. Same thing as critical values. Just different words for the same stuff. And solve. I'm going to add 2 to both sides. This cancels, so that's me 2x is equal to 2. I'm going to divide by 2, and I get x equals 2 over 2, which is 1. So the answer to where the horizontal tangent lines occur at is x equals 1. Now, if I had more than one answer, I would put comma and then type in the next answers if you got multiple answers. But there's only one for this one. So that was it. So I'm going to go to the next problem. Part 2 here is this. Now they want me to tell you the intervals of increasing and decreasing. Determine the open intervals in which the function is increasing and the function is decreasing, and we'll use the empty symbol, 0 with a line through it on that little keypad to indicate the interval is empty. So come back over here. So here's my problem that we just did, but now I want to find intervals of increase and decrease. So when you're doing intervals of increase and decrease, we're going to draw ourselves a number line, labeling with your first derivative type here. This is 1. Put your critical value on your number line, and do test values. Pick a number less than 1. I choose 0 because I have a brain, and plugging into your derivative. Remember, your second derivative was 2x minus 2. So this will be 2 times 0 minus 2. That's equal to negative 2. It's negative. And pick a number bigger than 1. I choose 2. Plugging in 2. 2 times 2 minus 2 into your derivative. 2 times 2 is 4. Minus 2 is 2. Don't care what the number is. It's positive. So it's positive here. This tells me in this problem that we are increasing on the interval between 1 and infinity. That's where it's positive at. And we are decreasing on the interval between negative infinity to 1. Remember, your arrow to the left is your negative infinity, arrow to the right is positive infinity. So here's my answer to the question. So now I just got to go type that up, and similarly what we did before. It is increasing on the interval, and I could go over here and click on the keypad, and to get an interval, you start with this guy right here. And the interval of increasing was 1, infinity. We use the infinity symbol right here. For intervals of decreasing, and just to kind of slide this out of the way, you can see it's decreasing there. Intervals of decreasing, parentheses here, it is from negative, and then you hit your infinity, comma, to 1. And just click out of it, and that's what I want, and that double checks to my answer. So I'll go to the next problem. All right, this one's kind of nice because they gave you a picture. Okay. Now, you're supposed to, quote, look at this problem. Let me just slide it all the way to the top here. You guys can read this thing. Consider the graph. Determine the open intervals on which the function is increasing and the function is decreasing. Enter the empty set symbol, 0 with a line through it, to indicate intervals of empty. Okay? Let's take a look at this guy. Now, anytime you describe a graph, you always describe a graph through the x coordinates and the x axis. The only time I ever use the y-axis is, the y-coordinates and y-axis is the word range. Now, I'm not asking about range. Intervals of increase and decrease, intervals of concavity, I always use the x coordinates. So if I look at this thing, I can tell you from negative infinity all the way up to this point right here. That point, when you count your hash marks, is 1. From negative infinity to 1, the function is increasing as you read a graph from left to right. Between 1 and this point here, which looks like 2, 1, 2, between this point right here, between negative 1 and 2, it is decreasing. It's going down. And then between 2 and infinity, it's going back up again. So I'm going to type that in here. It is increasing in 2 intervals. From negative infinity, so I'm putting in that parentheses, negative, and I got to go to my keypad over here, infinity, to this point right here, which was, when we looked at it, was at 1. Kind of check, there's your axis right there, so it's negative 1 actually, comma, negative 1. But they tell me that I have to use commas. Usually I use the symbol U for union on this thing, but to type it in the computer, you got to type in a comma, and then you type in your next interval. Your interval is, what was that from? From up here, it was from, let's see, 1, 2, from this point 2 to infinity. That's where it's increasing at. 2, comma, infinity. Where is it decreasing at? It's decreasing from negative 1 to 2. So I'm going to put my little ordered pair, open parentheses, from negative 1, comma, 2. Does that make sense? And then I go to the next problem. What does this one say? All right, we've got this function here. So off screen, I'll write it down as I'm reading it. Consider the function f of x is equal to, parentheses, negative 3x minus 7 squared. Find all values that correspond to horizontal tangent lines. Horizontal tangent line, slope of a tangent line, slope of a horizontal line is 0. So what we're really talking about, once again, where the derivative is equal to 0 at. And then we're going to, and then we're supposed to just define these guys, the x coordinates for this thing. So, and it also says down here, if you happen to have fractions, you need to put it as a ratio. Sometimes it won't consider a decimal. So, all right, so let me go back over here. You can see it. So my function here is negative 3x minus 7 squared. What rule do I need to do to take derivative of this guy? What rule am I going to use? Chain rule. Derivative of the outside, inside stays the same, times derivative of the inside. So derivative of the outside, the 2 pops out front, the inside, negative 3x minus 7 stays the same, raised to the first, times derivative of the inside. Derivative of the negative 3x minus 7 is negative 3. I'm going to clean this guy up. So f prime of x is actually equal to 2 times the negative 3 is negative 6 times negative 3x minus 7. To the first power means it's himself. And then I'm going to distribute, just to clean them up one more good time. Negative 3 times a negative 6x, negative 6 times a negative 3x is going to be a positive 18x. Negative 6 times a negative 7 is a plus 42. Does that make sense? I'm going to set it equal to 0, and I'm going to solve. I'm going to subtract 42 from both sides. That gives me 18x equals a negative 42. I'm going to divide by 18 on both sides, and I get x is equal to negative 42 divided by 18, and that fraction reduces, so let's reduce that. Negative 42 divided by 18 reduces to, let's see here, 42, both of them have 6 go into it. 6 goes into negative 42 negative 7 times, and 6 goes into 18 3 times, so the answer I get is x is equal to negative 7/3. Does that make sense? But now to type it in onto your Hawk system, because they said select the ratio button, you go to your keypad and you hit the fraction button. Okay? And the answer was negative 7/3, and you can put the negative on top or out front. That's up to you guys. So I'm going to put the negative out front just to make them look good. Whoop, I didn't mean to do that. So I'll put negative, and then I'll go back to my little keypad here, put the little fraction in there, 7/3. Now if you put the negative 7 on top, that's perfectly fine. It'll take it. Does that make sense? So let's go to the next problem then. Oh, question? Yeah.
Is a horizontal tangent line the same thing as a
Critical value.
Yeah,
Yes. Horizontal tangent line, critical value, that means the exact same thing. So the next part is, once again, we're supposed to find intervals of increase and decrease. So let me get back over here and blow it up so you guys can see it. So here it is, intervals of increase and decrease. My first derivative was this 18x plus 42. I'm going to draw a number line for him. I'm going to put my critical value of negative 7/3 on this guy. Now, negative 7/3 is also negative 2.33333, just to get a feel for what this guy is. So, because I want to pick test values. So this is your negative 2.333 thing here. Pick a number less than negative 2.3333. I choose negative 3. Good enough. F prime of negative 3. That would be 18 times negative 3 plus 42. So, putting on my calculator, say 18 times negative 3 plus 42 is negative 12. Now I did literally was just put it on my calculator there. Negative 12, which means it's negative, which means I am decreasing in that interval. Pick a number, use your brain, greater than negative 2.33. Of course, I'm going to use 0 because it's the easiest thing to plug in. That'll be 18 times 0 plus 42. That gives me 42. I don't care what the number is, it's positive. So everybody in that interval is positive. So I'm increasing here. So I am increasing on the interval between negative 7/3 and infinity, and I'm decreasing on the interval between negative infinity to negative 7/3. Does that make sense? So let's type that in. So come back over here. I'm increasing on the interval, parentheses there, and it gives me an order pair. Let's see here, it's increasing from, now, I need to put a fraction here because it wants to do the fraction, so this was negative 7/3, and then over, click it, comma, infinity. Notice this time I actually put the negative on top, it'll take it. And then for the decreasing part, put my set of parentheses there, it is decreasing from negative infinity, so click on the negative and then the infinity button, comma, to the fraction, negative 7/3. And the next one, they give me a picture again. Consider the graph determined by the open intervals on where the function is increasing, where the function is decreasing, and enter empty set for non-empty. So we got to look at this graph and figure increasing and decreasing. Remember, increasing and decreasing is based upon the x-coordinates number line. So if I look at this particular graph right here, I start over here at like negative 10 or something or other. I'm looking at this graph. The graph is going up. So it's increasing all the way up to this vertex right here. What is that point? That is the point negative 2, 5. But all I care about is the x-coordinate, all the way up to negative 2. So between negative infinity to negative 2, the function is increasing. So I'm going to come down here. Function is increasing from negative infinity, negative, hit my little keypad here, infinity, to the point negative 2. All right, and I'll scroll back up here. You can see it. So that point right there at negative 2. But once I hit that negative 2 point on the x, now the function is going down. And from negative 2 all the way up through infinity, it is going to be decreasing. So the answer is parentheses, negative 2, comma, infinity, it's decreasing. And then am I ready to submit? Sure. So, okay. And then submit quiz, click it up here. It's thinking about it. Make sure I click on it good. Submit it. Yes, I want you to submit it because I think I did good, but let's see what it likes. And what do I got? A full green circle. And you guys should know what that means. Yeah, I got it right. Does that make sense? Questions? I thought I'd also go in and look at some of the certify from chapter 4.1a. Okay, so let's go ahead and do that. So I'm going to go back over here to, I guess, my dashboard. And I'm going to go over here to my 4.2a. That's also due this weekend. And you can practice if you want to. And practicing is very good just to get a feel for what these questions are. Because when it comes to the certify, you know, you really are trying to get at least 80%. But I like 100%. So there you go. So let's get 100%. So I got 13 questions on this one. So. And again, I'm going to do the same thing. I'm going to do the question and then work over here on the right-hand side and actually write the answer, then come back and type it in. So this first one from section 4.18, again, this is due on Sunday for you guys. This one is f of x, you're given your problem, is equal to 4x cubed plus 2x squared minus 10x. You with me? This is your function. They asked me to find the second derivative. But to be able to find the second derivative, I've actually got to find the first derivative. So let me click over here so you guys can see what I wrote down. There's my function there. So I want to find the second derivative. So let's find the first derivative. Derivative of 4x cubed is 12x squared plus derivative of 2x squared is 4x and derivative of minus 10x is minus 10. Now take a derivative again. Derivative of 12x squared is 24x plus derivative of 4x is 4, derivative of minus 10 is 0. So my second derivative is 24x plus 4. So I'm going to come back over here and type it in. 24x plus 4. And on this one, it's just a classic function with no major powers or anything like that. So that was easy to do. So I'll submit my answer. And yay, way to go. Good. So let's go to the next problem. What does this problem say? It's a two-parter, so be careful here. F of x is equal to, and off screen I'll write down this function. F of x is equal to, what is it, 5x cubed minus 135x squared minus 8x minus 1. We are supposed to determine the intervals on which the function is concave up and concave down. Concavity deals with the second derivative, okay? So, and I got a couple places to put it in there, so let me come back over here so you guys can see what I'm doing. Second derivative. So I need the second derivative of this term. So f prime of x, the first derivative is going to be 15x squared minus 2 times 135 is what? 270? So typing it in, 135 times 2, just double checking me. I'm sorry, 270. 2 times 135 is 270. I'm double checking everything on my calculator because I only got one shot at this thing. Yeah, 270 x minus derivative of 8x is 8, and derivative minus 1 is 0. Now let's take the second derivative. Derivative of 15x squared is 30x minus derivative of 270x is 270, and derivative of minus 8 is 0. But I need to find the hypercritical values, aka the possible inflection point guys, so I'm going to take my second derivative, set it equal to 0, and solve. To solve this, I'm going to add 270 to both sides. So I end up getting 30x is equal to 270, and then I'm going to divide by 30 on both sides. And 270 divided by 30 should be 9. It is, double checking on the Google calculator just to make sure, but x equals 9. But that is my hypercritical value. That's my second derivative is equal to 0. That's my possible inflection point. They want intervals of concavity. That word interval means I'm going to draw a number line. Intervals of increase and decrease is a first derivative number line. Intervals of concavity is a second derivative number line. So I label them with the second derivative. I'm going to put my hypercritical value, my possible inflection number there, of 9 on the guy, and then I'm going to do my test values. Pick a number, use your brain, less than 9. I choose 0. And I'm going to plug it into my second derivative. My second derivative, again, is 30x minus 270. So 30 times 0 minus 270 is negative 270. It's negative, but this negative tells me I'm concave down. Does that make sense? Now pick a point bigger than 9. I choose 10. So f double prime of 10 would be 30 times 10 minus 270. 30 times 10 is 300 minus 270 equals 30. I honestly don't care what the number is. The fact is 30 is positive, which means everybody in that interval is positive, but this is with the second derivative. That means I'm concave up. So to answer their question, it is concave up on the interval between 9 and infinity, and it is concave down on the interval between negative infinity to 9. Does that make sense? So I'm going to go type that in now. Concave up, parentheses, it was 9 comma, and now I need my keypad for my infinity symbol there. Okay, and it is concave down. I'll put my little parenthesis there. When I type in parentheses, this automatically shows up. It's from negative infinity, so I need my keypad again. Negative infinity to comma 9. Does that make sense? Okay, I'll submit that answer and go, yay, fantastic. Okay. Yeah, question?
So the first derivative deals with the
Increase and decrease. First derivative deals with intervals of increase and decrease, when I'm going up and where I'm going down. The second derivative deals with concavity, U-shaped up versus U-shaped down. Okay. Notice it's the same function here, so it makes it pretty nice for me. It says part 2, locate any pairs, any points of inflection and enter the coordinate as a point, x, y, or a point of inflection. So let's take a look at what we did before. I went from going concave down, I hit 9, and then I'm concave up. I changed concavity. Because I changed concavity, we have a point of inflection. And that point of inflection is x equals 9. But they want a point. So I've got to have a y-coordinate. How do I find a y-coordinate? I find a y-coordinate by plugging the x back into the original equation, way back up here. So I'm looking for f of 9. This would be equal to 5 times 9 cubed minus 135 times 9 squared minus 8 times 9 minus 1. And I'll grab my little handy dandy calculator here and type it in. 5 times 9 cubed over arrow minus 135 times 9 squared minus 8 times 9 minus 1. I'm literally just typing it in on my calculator here, and I end up getting, lovely, negative 7,363, and that is my y coordinate, and that is my inflection point. So I'm going to type it in now. So go back over here. Now it's a point, so it's an ordered pair. So, but I'll use the same set of parentheses here as I did with intervals of increase and decrease. But now, so this is it. Okay, I went too many times here. So let's try again. Keypad there, and then I'm just going to slide this thing out of the way. There we go. And then what was my point? The point was the x-coordinate was 9, comma, the y-coordinate was a negative 7,363. Does that make sense? And then I'm going to X this out and then go submit, and boom, green. Yay, way to go. Okay. Now this was that problem we also did in class, whereas they gave me some information about this guy. So let me talk about this one for a second. It said this: there's at least one polynomial function which satisfies the conditions below. Okay, and that is big F of 7, big F of 7 is equal to negative 42. F prime of x is non-zero. And F double prime of x is equal to 0 for all x. And we got to come up with an example of this function here. So let me come over here. This is what they told me. Now, basically we're trying to get you guys to think about going forwards and going backwards with these derivative concepts. So I've got to have a function that when I plug in 7, I get negative 42. I've got to plug in where the first derivative is non-zero. If the first derivative is non-zero and the second derivative is 0, let's look at those two concepts together. If the second derivative is 0, I take the derivative of somebody and I get 0. What do I take a derivative of that's going to give me 0? It works every time. Derivative of what is always 0? Well, no, derivative of x squared is 2x. What's derivative of something that's always 0? What's derivative of 5? What's derivative of 5? 0. What's derivative of negative 7? 0. What's derivative of negative 432? Derivative of any constant is always 0. So for the second derivative to be equal to 0, that means the first derivative has got to be some kind of a constant. C for constant. Okay? It's got to be a constant. Now, and what do I take when I take a derivative of somebody and I get a constant? What did the original function have to be equal to? Derivative of what is a constant? What's derivative of 5x? 5. What's derivative of 17x? 17. So derivative of a constant times x is always the constant. So if the derivative is the constant, the original function had to be the constant times x. So let's double check. I don't know where that constant is yet, but we'll get him. Derivative of constant, if you got the function constant times x, the derivative is going to be a constant. And the derivative of a constant is always going to be 0. So it's satisfying all my conditions, except I got to plug in f of 7 equals negative 42. So if I know this is my modeling equation, f of 7 equals negative 42. F of 7 is equal to a constant times 7, but that's equal to negative 42. Remember, this is my function, so I'm plugging it in there. So, look at it. You got an equation. 7 times your constant equals negative 42. Divide by 7 on both sides. Negative 42 divided by 7 is what? Negative 6. Therefore, your function, which is equal to constant times x, but that constant had to be negative 6. The answer is negative 6x. And let's just double check. Look at this function, negative 6x. Double check it. What's f of 7? Negative 6 times 7, negative 42. First part checks. What's the derivative? What's the derivative of negative 6x? What's the derivative of negative 6x? Negative 6. That's not 0. What is the derivative of negative 6? 0. That is 0. All three conditions have been satisfied. That's got to be my modeling equation there, and that's what I'm going to type in. Negative 6x. Yay. All right. Now on this problem here, we got to determine the intervals where we have concave up and concave down. This thing's wiggling all over the place. So we got lots of concavity here. So, and I'm going to write it down on a separate sheet of paper as I'm doing it, and then we'll look at it. So, now for concavity, we're talking about concave up is where it's U-shaped up at, and concave down is where it's U-shaped down at. This is U-shaped up here. So starting at negative infinity all the way to this point right here. Okay? And if you count your hash marks, it's right in the middle. That is negative 5. So between negative infinity to negative 5, what are we? We are concave up. Does that make sense? Now, starting at negative 5 and look at the rest of the graph, from this point, and again, only focus on x coordinates, from negative 5 to this point right here, that is negative 1, what kind of concavity do I have in this section of graph? Concave down. So between negative 5 and negative 1, it's concave down. Does that make sense? Now picking back up at negative 1, from negative 1 all the way over to this point right here, which is how many hash marks? 1, 2, 3, all the way over here to 3, we're back to being concave up again. So from negative 1 to 3, it's concave up. Negative 1 to 3, it's concave up. Now picking it up at 3, from 3 pretty much on to infinity, this thing is going in a U-shape down, so it's now concave down. So it's concave down between 3 and infinity. Okay? So just to kind of pop it over here, I kind of wrote it down exactly what we were just saying. I talked about where it's being up at versus being down. Now traditionally when I lecture on this stuff, and proper notation says, when you talk about concave up intervals, and you got separate intervals, we usually use the U symbol for union. It's this answer and this answer. But Hawks tells you to separate your answers with a what? Comma. So don't put the U there, put just a comma. So that's how I'm going to type it in. So come back over here. Where is this function concave up at? It is concave up parentheses from negative infinity to negative 5. So it's got to type in my negative and then type in the infinity. And let me slide this out of the way so you guys can see what I'm doing here. Okay, negative infinity. Oops, negative didn't take. Negative infinity, comma, negative 5. And then instead of using that union symbol, you're supposed to put a comma to separate your answers, another set of parentheses, and it was from negative 1 to 3. It was concave down on the interval between negative 5, comma, and negative 1. And then we have one more interval, so you put a comma to separate them, a parenthesis from 3 to infinity. 3, comma, and then I click on my little infinity symbol here. Does that make sense? And that should match up to actually what I wrote down over here with the commas in there. So, and I'll submit. Yay, awesome. Does that make sense? All right, and this is part 2 of them. Quote, select the ratio button or will replace any kind of answers and values with the ratio button, but what are we supposed to do in this problem here on part 2? Maybe it's the answer questions up here. Oh, here it is. Determine the x coordinates of any inflection points. What is the definition of inflection point? It's the point where you change concavity. So this was concave up to this point, which was negative 5. Then it was concave down to negative 1. Then it's concave up to 3, and then it's concave down. So these points are negative 5, negative 1, and 3. Does that make sense? These were also the points on my interval that I was using. So I was supposed to type that in, and I got to separate one by constant. And if you have a fraction, you have decimal or whatever, you got to put it in as a fraction on this thing, but ours are just nice numbers, so I don't have to put any kind of fractions here. The answer was -5, comma, -1, comma, and what was the other one? 3. These were the quote inflection points where I changed concavity at. So here's another problem. It says, consider the function, and let me write it down over here. F of x is equal to 6x cubed plus 72x squared minus x. The first question asked you, find f double prime of x. Find the second derivative. Well, to be able to find the second derivative, you've got to go through the first derivative. So let me come over here to my little scrap sheet of paper here. Here's my function. So f of x was equal to 6x cubed plus 7x squared minus x. So your first derivative is going to be 3 times 6 is 18x squared plus 2 times 7 is 14x, and minus derivative of x is 1. Now your second derivative, derivative of 18x squared, well 2 times 18 is 36x plus derivative of 14x is 14, derivative of minus 1 is 0. So this is my answer. So come back over here. And I'm going to type it in. It's 36x plus 14. And with the simple functions, I don't need my keypad at all. So boom, I submit it, and I've done well done. And I go to the next one. But now it's the same function. And now we're supposed to evaluate these problems here. We're supposed to evaluate f double prime of 0, f double prime of -6, and f double prime of 5. The second derivative evaluated at 0, second derivative evaluated at -6, and the second derivative evaluated at 5. And again, if we got to type any kind of fractions, put it in fraction mode there. So put it back over here. So now, basically, it's classic algebra of plugging numbers into your function. In this case, it's the second derivative. F double prime of 0 is 36 times 0 plus 14. That's easy math. That's 14. F double prime of -6 is 36 times -6 plus 14. Oh, big numbers, use calculator. So here we go. 36 times -6 plus 14. And I end up getting -202. The last one is f double prime of 5. That'll be 36 times 5 plus 14. 36 times 5 plus 14 is 194. Does that make sense? So I'm going to go enter these guys into my Hawk system. So f double prime of 0 was 14. F double prime of -6 was -202, 202, and f double prime of 5 was 194. Does that make sense? Okay. Uh-oh, getting worse on me. So now they gave me a problem of f of x is equal to 3x plus 2 divided by 3x plus 4. And they tell me to find the second derivative. Alright, so here's my problem now. I want to find the second derivative. Of course, to find the second derivative, you've got to find the first derivative first. So look at this function. The function is 3x plus 2 divided by 3x plus 4. What rule you can use to take derivative of this guy? What's my rule? Look at the picture and tell me what rule. Quotient rule. Derivative of the top times the bottom minus the top times derivative of the bottom all over the bottom square. Derivative of the top. Derivative of 3x plus 2 is 3. Derivative of the top times the bottom. 3x plus 4. Minus the top, 3x plus 2, times derivative of the bottom. Derivative of 3x plus 4 is 3. Derivative of 3x is 3. Derivative of 4 is 0. All over the bottom, 3x plus 4 squared. Derivative of the top times the bottom minus the top times derivative of the bottom all over the bottom square. But that's the first derivative. And to be able to take the second derivative, I got to clean this guy up. So to clean this guy up, just be careful, watch the careless errors. I'm going to distribute the 3. This will give you 3 times 3x is 9x plus 3 times 4 is 12. This is a 3, and I can put him out front. With that is it's a minus, so I'm going to distribute the minus 3. Minus 3 times 3x is going to be a minus 9x. Minus 3x times a 2 is going to be a minus 6. All over 3x plus 4 squared. Now when you clean this up, I've yet to take the second derivative, I'm still cleaning it up. 9x minus 9x is awfully nice. 12 minus 6 is 6 divided by 3x plus 4 squared. Now, listen up and listen good. You can take rid of this guy the way it is, and it would be a quotient rule because you got a big divide in here. But always try to clean him up. And anytime I got something in the denominator with a power, I like to bring him to the numerator. So when I bring him up to the numerator, that'll be 6 times 3x plus 4 to the negative 2 power. And now to take rid of this guy, all I've got to use the chain rule. Remember, 6 is a constant out front. When you're doing derivatives and multiplication, constants hold over. So your second derivative is going to be, we'll hold that 6 over and bring down the negative 2. Negative 2 times a 6 makes it negative 12. Derivative the outside, chain rule. Derivative the outside, inside stays the same time derivative the inside. So derivative the outside would be negative 2 times 6 is negative 2. The inside, 3x plus 4 stays the same. Raised to the subtract 1. Minus 2 minus 1 is minus 3. Times the derivative of the inside. Derivative 3x plus 4 is 3. So I'm going to clean that guy up. 3 times a negative 12 is a negative 36 times 3x plus 4 to the negative 3. That's the answer. Or, if you wanted to clean them up some more, and this is perfectly fine as well, Hawks will take it either way. Negative exponents go back to where they came from, which is back to the denominator, but that negative 36 will stay where it's at. That's on top, over the 3x plus 4, and it becomes cubed. And I'll type it in like that because just to show you the keypad stuff. Does that make sense? But if you type this in, perfectly fine answer, it'll accept it. So let's show you. So keypad, I'm going to type it in as that fraction. The numerator was what? Negative 36. The denominator was this parenthesis. It was 3x plus 4. But then over arrow here, raised to, so this is my raised button there, raised to the third power. Does that make sense? And let's check it out, and it liked it. Does that make sense? And if you put the negative 36 times 3x plus 4 to the negative 3 power, it'll have to give you credit for it. It's absolutely right. So let's take a look at another one of these problems here. And that is f of x is equal to 2x squared minus 6x square root of x plus 1. So it's 2x squared minus 6 times the square root of x plus 1. Now I'm supposed to take the second derivative of this guy, so before I take my second derivative, I got to find the first derivative, and before I take any derivative, I got to clean it up. I don't do square roots. What's a square root also known as? 1/2 power. So cleaning them up, this is f of x is equal to 2x squared minus 6x to the 1/2 power plus 1. So f prime of x would be equal to derivative of 2x squared is 4x minus derivative of 6x to the half. Well, bring down your power. A half times 6 is 3x and subtract 1. 1/2 minus 1 is negative 1/2. And derivative plus 1 is 0. So there's my first derivative. And he's already in cleaned up fashion, so he's ready to take the second derivative. The second derivative of 4x is 4 minus 3 is a constant. Derivative of x to the negative 1/2, you bring down your power, negative 1/2 x and subtract 1. Negative 1/2 minus 1 is negative 3/2. But I wrote it like this so I could show you what I was doing, because I didn't want to do too much in my head here. So f double prime of x would be equal to 4. A negative times a negative is a positive. 3 times a half. 3 times 1 is 3, and divided by 2, so that's 3/2. X to the negative 3/2. There's my second derivative, and this time I'm going to type them in exactly like this. I mean, I could clean them up by putting this x to negative 3/2 down the bottom, makes it 3 over 2x to the positive 3/2. That's just semantics. It'll take it either way. So my derivative was 4 plus I had a fraction, so let me use my little keypad for my little fraction. My fraction was 3 over 2. I'll over arrow on this one there, and I got to do x, but I want to raise him to a fraction, and that fraction was negative 3 over 2 power. And this is the way it looks, and I'm just comparing it. I'll go back and look at my answer. 4 plus 3 halves x to the negative 3 halves power. So let me go, and that looks right. And then so I submit, and yay, it liked it. Does that make sense? The hard part about this stuff, honestly, is, and we understand this, is typing in and get everything just in the right details to make sure that the computer is happy. And that's your job. 21st century, make the computer happy. All right. Now we got some word problems. Let's take a look at these guys. The sales function for a product is given by S of x. Let me write this down off the screen here. S of x is equal to 126 plus 30.6 x squared minus 0.6 x cubed. Where x represent thousands of dollars spent on advertising between 0 is less than or equal to x, which is less than or equal to 34. And s is also in thousands of dollars. Okay? Find the point of diminishing returns. Now, we talked about him before. The point of diminishing returns is where the second derivative changes from being concave up to being concave down. So the first thing I got to do is I got to find this possible inflection point, also known as the hypercritical value. So, pull my little screen up over here. So I wrote down the function for you, but to find this hypercritical value of this particular function here, I got to find the second derivative. To find the second derivative, you got to find the first derivative first. Derivative of 126 is 0. The derivative of 30.6 x squared, where 30.6 times 2 is 61.2x, just 2 times 30.6, and I want to show you, I just did that on the calculator just to make sure I didn't screw it up, minus, what is 0.6 times 3? 0.6 x cubed, that would be, bring down to 3. 3 times 0.6 is 1.8 x, and subtract 1 squared. There is my first derivative. Now I'm going to take derivative again to get the second derivative. Derivative of 61.2x is 61.2. Minus derivative of 1.8x squared, well, 2 times 1.8 is 3.6x. And now to find the hypercritical value, I'm going to set it equal to 0 and solve. So I'm going to move this term to the other side. So 61.2 equals, add 3.6x to both sides. Gives me 3.6x, is that what it canceled? And then I'm going to divide by 3.6 on both sides. And I get x is equal to, and grabbing the old handy dandy calculator, I'm going to get 61.2 divided by 3.6 is 17. And I always feel better when you get a nice answer like that, 17. All right? But I'm going to show you that this is going to be the hypercritical value. But the next thing is this. Look at your answer. I got 17. Pause for just a second. Look and compare. Is 17 in that given interval? Is that between 0 and 34? Yes, it is. Okay? Now, to show you that it's, quote, a point of diminishing returns, I'm going to draw my little second derivative number line. Here's 17. All I care about is between 0 and 34. So I'm going to pick a number less than between 0 and 17. I choose 1. So S double prime of 1. If I plug in 1, and your second derivative, because I wrote over it, I'll write them again, is 61.2 minus 3.6x. That's what I'm going to plug in. So, plugging them in, 61.2 minus 3.6x, but x is times 1. I get 57.6. I don't care what the number is, it's positive. That means I was concave up. And pick a number bigger than 17, I choose 18. and it's plugging in 1861.2 minus 3.6 times that 18. Let's just see what the number is. I get negative 3.6. I don't care, it's negative. That means I'm concave down, and that is the definition of your point of diminishing returns. It is a changing from positive concavity to negative concavity. So the answer is x equals 17. But now let's look at the question, because they asked you a question in an interesting sort of way. And they put units on this thing. Now we got x, and they wanted you to check the box and play enter and check the value, and they want to know what was the amount spent on advertising. So x is the amount spent on advertising, and s was sales, and that'd be your total sales. So what they really want in this problem is a point. Okay? And you got to put the point in the right thing. So, in the right format. So, I want my point. So, my x coordinate was 17. So, let's go back over here. So, if my x point is 17, how do I get my y coordinate? What am I going to have to do? Plug them back into the original equation. So, and I'll do that on the calculator here. So, this would be officially s of 17. This would be 126 plus 30.6 times 17 squared minus 0.6 times 17 cubed, and I get 6021.6. And double checking me here, but that's good. Squared, and just double check it, make sure I typed it in right. Yep, there it is right there. But now remember your units. So, what was x? X is measured in what? And they bolded it for you guys, and I'm highlighting it now. Thousands of dollars. So, what does 17 actually represent in terms of dollars? 17 thousands of dollars. So, how much is that? That's $17,000. Does that make sense? And wait, it gets better. So, this answer in advertising should have been $17,000. And what was my total sales? Now look at the problem. It says, now in thousands of dollars on advertising, and S is measured in, what is it? They bolded it again. What did they measure it in? Thousands of dollars. So it gets better. So now, the Y coordinate, this is your S, but you got this 6,021.6 in thousands of dollars. How much is that? Good. So you basically multiply this times 1,000, and I'll do that for you guys, just to show in the calculator, because this is 6,021.6 thousands of dollars. To turn into dollars, you multiply by 1,000, and that gives you got it, $6,021,600. Because they want it in dollars. Does that make sense? You got to actually pay attention to the units on this stuff. So I'm going to come over here and type that in. $6,021,600. Yay, it liked me. Okay, but you know that half the people in our class, they're going to type in 17 and 6,021.6. And they go, it told me it was wrong. No, it's you didn't pay attention to units. It's in thousands of dollars. Give it what the people want. Yeah, but I would accept it as you can make it $17,000. But if you were to put x equals 17 and write thousands of dollars, I would also give you full credit for it. So how did I do? I got 11 correct out of 11. Yay, I got them all. Hey, congratulations. There you go. Does that make sense, though? And notice how I did that last problem stuff. I hope this helped out. Did this get a better feel for this? And I am recording this for the folks that didn't make it here, because I'm sure they would like to see what one of these review sessions are like. So we will put it up on the web, and you guys can take a look at it, and we'll send it out to everybody this weekend. So there you go.